Hello and good day, geometry. We'll be covering CO31, which is finding all possible lengths of the third side of a triangle when given two of its sides. So this kind of piggybacks off of PO30, where we talked about the triangle inequality theorem. The triangle inequality theorem, which is Theorem 512 here, I'll kind of do it up in this top part. We know that given a triangle with sides A, B, and C, we know that A plus B has to be greater than C. Right? The sum of two sides of the triangle must be greater than the third side. And we also talked about how, technically there are three inequalities that can be written. A plus C is greater than B, and B plus C is greater than A, right? But if you identify C as your longest side, then you really only need to add A and B together, the two shorter sides, because if C is your longest side, then if you're adding something to it, of course it's going to be greater than one of the shorter sides. Okay, so really this is the inequality that we kind of focus on there: A plus B greater than C. And so I've got a triangle, and no, not that triangle game, with side lengths of 13, 19, and n. So I know two of the sides. I'm missing that third side. And based on the triangle inequality theorem, what is a possible value that n can be? Okay, and here's where we tie in these three inequalities that we have written down: 13, 19, and n. I know that 13 plus 19 has to be greater than whatever n is, right? Because the sum of two sides must be greater than the third side. I also know that 13 plus n has to be greater than 19. And I know that 19 plus n has to be greater than 13, right? Those are the three inequalities that we can write based on the triangle inequality theorem, kind of like the three inequalities that we wrote up above. But not knowing whether n is our longest side or not means we can't just focus on one of these. We have to actually focus on two of them. There is one we can eliminate. See if you can take a look at those three and decide which one we can eliminate, because it's kind of like, well, yeah, of course. Okay? It's the third one. 19 plus n is greater than 13. Because if 19 is already greater than 13, since n can't be a negative number, right? We can't have a negative side length of a triangle, then, well, yeah, this one we can eliminate because 19 is already bigger than 13. Whatever we add to it will still be bigger than 13. So we're really going to be focusing on these two inequalities here. 13 plus n, or if we simplify that, 32 is greater than n. And our second one, 13 plus n is greater than 19. If we subtract 13 from both sides to kind of solve this for n, we get n is greater than 6. Okay? And what these two inequalities give us now are a compound inequality, a range of values that n can be. N has to be both greater than 6 and less than 32. Remember, we can rewrite 32 is greater than n as n is less than 32. We can reverse the values on each side of the inequality if we also reverse the sign. So this tells us that n is between 6 and 32. Or going back to CO16, where we learned about compound inequalities and algebra, n is between 6 and 32. 6 is less than n, which is less than 32. Okay? Any value within that range of numbers is going to make this work. Let's just pick one. Let's say that n is 29. Okay? If we plug that into our two inequalities here, the two that we focused on, is 13 plus 19 greater than n? Is 32 greater than 29? Yes. The other side, is 13 plus 29 greater than 19? Yes. So 29 works. Okay. What about Can't erase that without erasing everything else, so I'll just cross it out. What about 11? Okay, 11 is also between 6 and 32. Plug it into our first one here. 13 plus 19, is that greater than 11? Yes. Is 13 plus 11 greater than 19? Yes. Okay, so it works, right? So using compound inequalities, we can describe the values that n could be. Let's scroll on down. It says write 3 inequalities based on the triangle inequality theorem, Theorem 512, then describe the possible lengths of n. And what I'm looking for here, the possible lengths, how you can describe them, is through a compound inequality. Okay? So 9, 15, and n. What 3 inequalities can we write from this? Well, we know that 9 plus 15 has to be greater than n. We know that 9 plus n has to be greater than 15. And we know that, what's our third one here? N plus 15 has to be greater than 9. One of those we can eliminate because, again, that third one, 15 already being greater than 9, doesn't matter what n is. If we add something to 15, which is already greater than 9, it's still going to be greater than 9. So that one's not really all that helpful. But from these other two, what we get here, 9 plus 15 is greater than n. We can rewrite that to be 24 is greater than n. And 9 plus n is greater than 15. I can subtract 9 from both sides, and that gives me the inequality n is greater than, once again here, 6. Okay. So what values could n be? Remember that 24 is greater than n is the same as n is less than 24. So if n is less than 24 and n is greater than 6, it means that n is between 6 and 24. Okay? N is between 6 and 24. Okay? Let's do another one. Let's do the third one here. Actually, no, you probably want the last one. Yes, of course you want the last one. I should know this by now. The last one, we're going to go. So 3 root 81, 2 root 225. Normally, taking geometry, you'd have already completely finished algebra where we would talk about how to evaluate expressions such as 3 root 81. But really, all this means is 3 times the root of 81, right? 3 times the root of 81. And following the order of operations, we would do the root first in PERMDAS. Roots come before we multiply. So the root of 81 is 9. Really, all this is 3 times 9, or 27. The second one, 2 root 225, really just means 2 times the root of 225. The root of 225 is 15. So 2 times 15, which is 30. Okay. Jot these notes down. I'm going to erase that in a little bit so I can... actually, you know what? No, I'll keep that up there. I'll just do my work kind of over in place of this third one here so that I can make it fit. So 27, 30, and n are really the 3 sides of this triangle. So what inequalities can we write? Well, we know that 27 plus 30 has to be greater than n. We know that 27 plus n has to be greater than 30. And we know that 30 plus n has to be greater than 27. Okay, going back to 2 sides, the sum of 2 sides must be greater than the third. These are the 3 combinations that must be true. Well, the one we can eliminate, 30 plus n is greater than 27 because 30 is already greater than 27. That one doesn't really make any sense here. Okay, so 27 plus 30 is greater than n. We simplify that and we get 57 is greater than n. The second one, subtract 27 from both sides. We get n is greater than 3. And of course, just like the others, I will remind you that 57 is greater than n is the same thing as n is less than 57, right? So n is less than 57. It is also greater than 3. That means that 3 is less than n is less than 57 and is between 3 and 57. This is a very wide range, right? But with those other two sides being pretty close together, it gives us a pretty wide range, that third side n, okay? And so maybe some of you at this point, I will save the other two for the Google quiz that you'll have. So do them, but you'll just kind of input your answer on the Google quiz. But maybe some of you are kind of noticing a little bit of a shortcut here. Some relationship between the two given sides, which I'll underline here. I'll do it in black. The two given sides, 9 and 15, and the kind of the bookends of our range here. What relationship do you see between 9 and 15, and then 6, and then 9 and 15 and 24? Or what relationship do you see between 27 and 30 with 3, and then 27 and 30 with 57? Okay. Well, if we label 9 and 15 as A and B for no particular reason, just so I can use variables here, notice that the small end of our range, that 6, is the difference between B and A. B minus A. 15 minus 9 gives us 6. The larger end, that other side, that 24, is the sum. A plus B. 9 plus 15 is 24. The other one, 27 and 30, well, 30 minus 27, B minus A, gives us the lower end, the 3. 27 plus 30, A plus B, gives us the high end, 57. Isn't that great? Now, normally we would go through several more of them. I would have you do the homework, writing all these inequalities, and then just in true Schultz form, I would give you the easy way, quote unquote, the easy way or the faster way after you've practiced, kind of the less efficient way. But what I want you to see, and being this recorded lesson, don't have the opportunity to really do that. But what I want you to see here, why do we write all these inequalities? It's to show you that triangle inequality theorem is useful to us. Not only can we use it to determine whether or not three sides make a triangle, but we can also use it to give us an idea, some sort of range of what that third side could potentially be, right? And we can use inequalities for that, but we also have this shortcut here. So you will need to know how to do both of them for the quiz, both the inequality way, writing them all out, okay, and then you can use the shortcut to kind of check your answer as well. The real world, it says you are touring the Twin Cities with your foreign-born cousins, and the three sites they want to visit are the Cathedral, Target Field, and Guthrie Theater. From the Cathedral to the Guthrie is 8.67 miles, and from the Cathedral to Target Field is about 9.93 miles. Describe the possible distances you'll have to walk from Target Field to the Guthrie. Okay, let's draw this out. That's a lot of words. So we have the Cathedral, which we will label point C. We have Target Field, which we will call point T. And we have the Guthrie, which we will call point G. Okay. Now we're just sketching here, so I'm not really interested. Is my figure drawn to scale? Is it perfect? No. Are these actually the locations? If you look on a map of these three landmarks, I don't know, and I don't really care, right? All I'm doing is I'm using this to give me an idea. Okay, it certainly looks like an isosceles triangle. Give me an idea of some distances. So it says from the Cathedral to the Guthrie is 8.67 miles. So 8.67 for the the cathedral to the Guthrie. And then from the cathedral to target field is about 9.93 miles. Okay, and the question is, describe the possible distances you will have to walk from target field to the Guthrie. We'll label that side N. Okay, so using the triangle inequality theorem, we know that the sum of two of these sides must be greater than the third. So the three inequalities we can write, 9.93 plus n is greater than 8.67. We know that 9.93 plus 8.67 has to be greater than n, that third side. And we know that n plus 8.67 must be greater than 9.93. Okay, those are all the combinations that must be true for this triangle to work. The one we can eliminate, I actually wrote first this time, right? 9.93 is already greater than 8.67, so that one's not going to be any use to us. Looking at the second one here, okay, if we combine 9.93 with 8.67, we get, what was that, 18.6. 18.6 is greater than n. And if we subtract 8.67 from both sides, what do we get? 1.26, or n is greater than 1.226. I didn't have my this is a decimal. I didn't have my Wheaties for breakfast today, so I'm just going to save myself the embarrassment of doing the rest of it wrong and just double check on the old calculator. 8 minus 8.67. Oh, 1.26. Oh, good. And then 9.93 plus 8.67. 18.6. Oh, good. Okay. Math is correct. So anyway, 18.6 is greater than n. We can rewrite that to be n is less than 18.6. If n is less than 18.6 and n is greater than 1.26, there's our low and our high end of our possible walking distances. I certainly hope it's more on the 1.26 side than the 18.6. Of course, the shortcut here would be to subtract the values to get that 1.26, and then add the values to get the 18.6, okay? And those will give you the ranges. So one way is to write those inequalities out, which is kind of the why this works. What are we doing? We're using the triangle inequality theorem. What actually ends up happening, though, that shortcut is just subtract the values to get the low end, add the values to get the high end. The brain buster here says a triangle has a third side length of 6 is less than x is less than 22. What this basically means is that we've got this triangle. We know two of the sides, and based on those, we know that the third side is somewhere between 6 and 22. What are possible lengths of its other two sides? Well, what do we know? If this is true, and we're actually going to use that shortcut to kind of help us here. If this is true, and we know that this 6 came from subtracting our two known sides, b minus a, and this longer side came from adding our two, or the high end of the range came from adding our two sides a plus b, we're basically looking for what two numbers give us a difference of 6 and a sum of 22. What two numbers that when you subtract them give us 6, so there's 6 apart, and then when you add them, give us 22. Oh, well, you might want to, start to play with numbers a little bit here. Like if you pick numbers that are 6 apart, let's say we're guessing that b is 13 and a is 7. 13 minus 7 would give us 6. Is 7 plus 13 22? No. So that doesn't quite work. It fits one of them, but not the other. Okay, let's see. What if we try, well, we were pretty close, right? 13 plus 7 give us 20. Let's try 14 and 8. 14, oh, right in the, there we go. 14 minus 8 equals 6. And 8 plus 14 equals 22. Excellent. Okay. So we know that this triangle that's being described here, and again, I'm just sketching, not really paying attention to distance or anything like that. We know that one side is 8, one side is 14, and that third side, n, has a range between 6 and 22. Okay? So you can also kind of go backwards, understanding that shortcut, that b minus a and a plus b is how we get the low end and the high end here. We can kind of guess and check to get the other two side lengths. Okay, there is math behind this, and this part I will say for you to kind of figure out on your own. Other than guessing and checking, what are other ways that you could arrive at 8 and 14? What patterns do you see, if there are any patterns here? Okay, what do you think? Okay, and then the second one, a triangle, is the third side length between 31 and 111. Remember, this 31, the low end of this range, came from subtracting the other two known sides. And the high end of this range, the 111, came from adding the two known sides. So what are those two known sides? What two numbers would subtract to give us 31 and then add to give us 111? That will be on your Google quiz as well. So there you have it. All right, that's it for today for this lesson. This was CO31. We're done with the unit after CO32. CO32 will drop on Thursday. I'm sure you can't wait for that. But after that, our unit's finished. So next week, you can expect a test on this unit. As all other ones, I'll have a practice test for you. You'll need to stay after school one of the days next week to take it, and we'll talk more about that as the time draws near, but just so you kind of know what's coming ahead. So that's how you math. Don't forget to like and subscribe. Hop on over to Google Quiz to take the quiz for the lesson. Have a tremendous day. We'll see you tomorrow.